This is 9-2's homework assignment in the textbook. We're on page 534 and we're doing numbers 1 through 13. So looking at number 1, it says solve this using the graph at the right. So we're not going to do any algebra here. We'll do plenty of that later. So we're going to use the graph. And so the graph of negative 4x squared is right here, and it's an upside down parabola. We talked about it's negative, so it points down. And we basically want to know, when does this equal negative 100? What x values do we put in to create an answer of negative 100? So we look at the parabola, and we're just going to look at when the y value, or when the function, this is the y value, the function, when is it negative 100? And so if you put the line negative 100 on your graph for y equals negative 100 and see where it hits your function of negative 4x squared, you can find the x values. And so here is your negative 100y. And so right here, now you kind of have to guess, but you can see it's directly in between the 4 and the 6. And of course, you could double check yourself by actually running the algebra here. But it's going to be at negative 5, and it's also going to be at positive 5. So it's going to say x equals, now you could list them out, positive 5, negative 5, or you can say plus or minus 5, and that means that either answer are part of the solution set, so it's both of them. So if you wrote x equals 5 comma negative 5, or you said x equals 5 and negative 5, okay, those are both correct. Okay, but you're going to see on the answer key everything is just plus or minus 5. When we get to these types of questions on the quiz, when we're solving them algebraically, I'll probably just ask for the positive version so that it's just easier. So you would just say the answer is 5 because that's the positive answer. And of course, I could ask for the negative answer. You'd say negative 5, but I'm just giving you a heads up. It's just more difficult when we have these computerized tests, as this is during the coronavirus quarantine when this is being recorded, that on the test I will ask for the positive version. If I'm using this years later and you guys are not on quarantine when you're watching this, congratulations. And your test will be obviously different than the ones that we're taking it online. But for us, we are going to look at this as plus or minus negative 5 on the test. You only need to worry about the positive version, and I'll be very specific about that in the question. Okay, going to number 2, we're going to solve this one now using the table. So we need to start to recognize that this left side of the equation, left of the equal sign, okay, that's the function, 5x squared plus 7. It's producing the answer of 7.8. We want to know what's the x value that's doing that. So here are all the possible x values, or at least the ones we're going to look at. And we want to know, out of these, which ones produce a 7.8 y value, or the answer to the function. So if you notice, we'll have a 7.8 here and a 7.8 here. That's the value that this function is producing when x is negative 0.4 and when x is 0.4. So it's positive and negative, x equals plus or minus 0.4. And of course, you could solve it algebraically, and it would also give you the same answer. But this is using a graph and using a table. So now we're going to jump into the algebra, solving this algebraically. So if x squared equals 40, just your basic problem, just reminding you how to do this. We want just x, so we take the square root of both sides. So x equals, now notice that the question doesn't tell you specifically how to leave your answer. So it's kind of open to you. You can leave it as just square root of 40. You could plug that in your calculator and take the square root. And for the sake of doing this online, let's jump back and use the online calculator. So if I was taking the square root of 40 and it didn't tell me how to round, I get this. So I could say, which is approximately 6.32. That's fine, or however you chose to round it. But remember, I could simplify this radical 40 and leave it in simplified radical form. And if the question asks for that, you have to be able to do it. So let's remind ourselves from just the last quiz how we do that. Split this into 2 pieces. One of them's got to have a square root. When I look at 40, I think 20 times 2. Neither one of those, 20 or 2, has a nice square root. But 10 and 4 do because square root of 4 is just 2. So I could simplify this. Square root of 4 becomes positive 2. We put it up front, and square root of 10 stays separate. And to show you that that is equal to square root of 10, and you get the same answer. So you can see you have square root of 40 equals this decimal answer, and square root 2 square root of 10, or 2 radical 10, which is the simplified version of square root of 40, also equals this. So these three are all equivalent to each other. Depending on what the question is asking for in terms of the directions, you'll have to give a specific one, but on these questions, any of these would be accepted because the directions were not very specific. All right, for the remainder of these questions, if I need a calculator, I'm going to go to my handheld graphing calculator, but just remember that you have access to the online calculator. If you go back to Monday, the directions are all posted there for you. All right, let's get into some real ones now. Number 4, 3705. All right, so kind of looks like a two-step or a one-step equation, but we've got this squared. We're going to isolate the y squared until it looks like this, and then just take the square root. So first thing we got to do is move this 436. So we're going to have y squared by itself. And now we're going to take the square root so that we can get rid of the squared, and it's just y. And you could leave it. This would not be one I'd want to sit there and try and simplify, and I would never give you something that big to simplify. Okay, so we could leave it like this, or we could go ahead and plug it in and get the decimal answer. And so it's approximately 57.1. If you were going to leave it as one more digit here, you'd have to bump that 7 up to an 8 because of the 5. I'm going to go 3 digits, and I can leave it a 5 because next to it is a 1. But again, there were no directions, so go as many digits as you want. Number 5. So again, each time a little more to it. I always want to get this v squared by itself, like a normal two-step equation. I'm going to move this first, save the one that's attached, divide by it to get rid of it, and then I'm still going to have to square root. So it's just one extra step compared to a two-step equation that we were used to. So we're going to add 24 to both sides. That's going to be 60 divided by 12, and that's 5. And so we're going to go ahead and take the square root of 5. And so you could leave it x equals square root of 5. You could go ahead and find the square root of 5. Approximately 2.24 if I round it there. And for all of these, we have to remember that a square root, one number times itself, gives you 5, or it gives you whatever it is. You're looking at the positive and the negative version will do that when you square them. So technically, we do need this to be plus or minus square root of 5, plus or minus 2.24. Same thing would be up here. Every square root answer needs a plus minus. There's always two possible answers here. So plus minus, plus minus. Again, that's because 5 times 5 equals 25, which means the square root of 25 equals 5. But negative 5 times negative 5 also equals positive 25. So the square root of 25 also equals negative 5. So we have to account for both of them. That's just a reminder on why we have to write that plus minus. Both are possible answers. Every square root has a positive and negative answer. Okay, number 6, pretty straightforward. We're going to isolate that variable by dividing. So w squared equals 400 divided by 5 is like 40 divided by 5, so 80. And we're going to square root 80. And that's going to be approximately, my answer would say W equals positive or negative square root of 80, which is approximately plus or minus 8.94. Okay, and if you wanted to simplify this, you could, but for now, let's just keep moving. We're past the simplifying. We're really focused on the algebra here. All right, now where it gets interesting. Number 7. So we've got this entire quantity being raised to the second power, and people want to distribute it, and there is some truth to what you can do and can't do there, but I'm going to show you the best practice here, what you want to do. So since this is the squared thing, when we take a square root, it will eliminate it. And so just like we always try to get it down to say x equals whatever and then square root it, we're going to try and get it down to this quantity squared equals and then square root it. And then that just goes away and we're left with just the a plus 5 once we get it there. But we really don't want to get to that step until we've gotten rid of this 3, because otherwise we're taking the square root of the 3 and things can get messy. So what we want to do is we want to get rid of this. 3 is being multiplied by this whole quantity. So that means I can divide both sides of my equation by 3 to get that off of here. Imagine if you knew what this number was, you plugged in, you'd add it to the 5, you'd get this number, you'd square it, and now you have an answer. Whatever it is, let's just say it's 4. Okay, and then you're timesing it by 3 to get 12. And so what I can do is I could work backwards and divide both sides by 3 to undo that. Okay, so just like when we see 3x equals, say, 15, we know that we can divide both sides by 3. This is the same thing. 3 is just being multiplied by an entire quantity as opposed to just x, but you could represent all of this by x. Okay, so we just need to see that it works the same. So 3 is going to go away, leaving me a plus 5 squared. 12 divided by 3 is 4. Now I'm going to square root this because I want this square out of here. When you take the square root of a square, you end up just like the square root of x squared is x. The square root of this squared is just a plus 5. Now, we took a square root. So this can equal both positive and negative 2. And you saw in your notes, that's where you have to now solve this separately. So we're going to solve it a plus 5 equals positive 2. And we're also going to solve it a plus 5 equals negative 2. So there's 2 possible answers because the square root could give us either or. So we're going to minus 5 on both sides here. So a could equal negative 3. I could also minus 5 here, and a would equal negative 7. And so my final answer, I want to express both. So a equals negative 3 or a equals negative 7. Number 8. So I already have the entire quantity squared on a side by itself. I don't have that extra number in front, like a coefficient that I need to get rid of. So my first step is actually going to be to square root both sides here, so this squared goes away. So 7v minus 2 is now alone. The square root of 81 is positive or negative 9, because 9 times 9 is 81, but negative 9 times negative 9 is also positive 81. So we have to solve this both ways. 7v minus 2 equals positive 9, and 7v minus 2 equals negative 9. So I'm going to add 2. And that's 11, so divide by 7. Final answer I'm going to leave as a fraction, 11 over 7. If you divided that and got a decimal, that's fine. Adding 2 to both sides gets you negative 7 divided by 7. 7 divided by negative 7 is negative 1. So there's our 2 possible answers. So really, once you understand the rules and how to follow them there, okay, not too bad. Okay, number 9, one of these problems where you drop something and gravity is affecting it. Say distance equals 16 times t squared. That's one that you need to memorize. Anything on the quiz with this, I will give this formula to you, but it's pretty easy to memorize at the same time. So let's start with letter A. You drop a stone into a deep well, carefully time how long it takes, blah, blah, blah. If it takes 2.4 seconds, so you're either plugging in for distance or time. 2.4 seconds goes in for time. So distance equals 16 times 2.4 squared. So we have to solve this out. Now it's going to ask you how far from the top. So they're asking you for distance. How far? So all we have to do is just run these numbers here. Pretty straightforward. Follow your order of operations. Exponents first. 2.4 squared. So we're going to have 16 times 5.76. And distance equals, you could write the actual distance. It says about how far though, so they're kind of asking for a round number. So I would say, since it's close, I would say about 92, and this is talking about feet. In part B, so a totally different question. If the water was 64 feet from the top of the well, how long would it take? So they're giving you distance. They're asking how long. They're asking for the seconds. So plugging into this, but now we're given the distance. So 64 goes in for D. And we don't know what T is. So we have to solve for the number of seconds. So we're going to go ahead and get this 16 out here. We want this to just say T squared equals, and then we'll square root. So dividing both sides by 16. 64 divided by 16 is a nice 4. 4 equals T squared. So we're going to go ahead and square root. So square root of 4 is 2, but remember, it could be positive or negative, right? So would you put plus or minus 2 in this situation? The answer is no, because what does this represent? It represents time. We're not going to have negative seconds here. So T equals a positive only, which is 2, or 2 seconds. I'm going to get a new page for number 10 because I'm going to be doing a little drawing. So number 10, we're going to draw this. A 30-foot ladder is placed against a wall. So here is my wall. And the ladder is not going to stand straight up and down, right? The ladder is going to go out. And it's going to hit the ground. So my ladder is up against the wall. Like this is a house. Forgive my non-artistic drawing. So the ladder itself, if you measure the ladder, is 30 feet. And it's against the wall, and the bottom of it is 9 feet away from the wall. So the bottom of the ladder to the wall is 9 feet. You should recognize that this is a nice right triangle, and you should start thinking Pythagorean Theorem. A squared plus b squared equals c squared. You're going to always see that pop back up. Again, it's only for a right triangle. So if you start drawing a picture and you realize, oh, that's a right triangle, I have 2 of the sides. I need to find the third one, which in this case, how high up the wall is the ladder leaning? Because it's not 30. It would have to be leaning perfectly up, straight up and down against it to be 30. So this is going to be less than 30. This is our hypotenuse, which means it's our C. That's the most important part of these. So I know that 30 has to go in for C. The other 2, the legs that come out from my 90-degree angle, are going to go in for A and B, and it doesn't matter where you put them. So I'm going to do x squared plus 9 squared, but if you had it reversed, that's fine. And to solve this, we're going to expand everything out. So 9 squared is 81. Can't do anything with x squared. And 30 squared, think about what 3 times 3 is. So when you do 30 times 30, it's 900. Minus 81, we want to get that x squared isolated, so it's all by itself, and we can square root it. So this is going to be 800. If I took 80 away, it'd be 820, so this is 819, and I'm going to square root that to get x by itself, because if I'm going to give this measurement, like a real life measurement, because this is supposed to be a real life word problem, right? I'm not going to tell somebody that the distance up the wall is the square root of 819. I'm going to give them an actual number. So square root 819. And of course, we'll round that off a little bit. So I'm going to say about, because I'm going to round it a little bit. 28.6 feet. Okay, number 11. Area of a circle. Let's stop right there. Area of a circle. Area equals pi r squared. That's one you don't want to forget. So it's expected that you know that. We're going to plug in. The area is 100. Area is 100. So this is 100. The area is 100. What do we not know? We don't know the radius. Okay, what is the radius of the circle? And it says to the nearest hundredth. So we will be rounding this as a decimal, nearest hundredth, tenths, hundredths. So all I need to do is solve this for the radius. So pi is a number and it's attached. So right now I need to divide both sides by pi to get rid of it, leaving me just r squared, just like if there was a 4 or 5 or a regular number in front. So I need to do 100 divided by pi. Now, if let's say you didn't have a graphing calculator, scientific calculator, you just have a little basic calculator, but all of you have phones, right? So you can do this on your phone. I'm showing you the scientific calculators. Let me grab that. So even if you have just a phone, you can do pi here. So regular calculator, turn it sideways, becomes a scientific calculator. A little hard to see there, but my pi button's right here. You should be able to find pi. So I would do 100 divided by pi. And there's my answer, just like if it was here. Okay, so if you're scrambling and you don't have a scientific calculator, use your phone. All right, so we have this number, right? And we're going to have to square root that eventually. If you want to write it out here, you could. I'm going to leave it as 100 over pi and square root here. So r is going to equal the square root of this number. If you do have a graphing calculator, you don't need to write that whole thing down and then type it back in. I can just hit square root and then scroll up, hit enter on that one, and it's going to bring it down and put it right there underneath and hit enter. And it said nearest hundredths, so we're going 2 spots, tenths, hundredths. We're keeping the 4 because the one next to it doesn't change it. So 5.64. Again, really handy if you have a graphing calculator, but lots of ways around that. Don't need the graphing calculator. All right, solving some more complicated looking equations here. I need to do a good job with my handwriting with the Z. So similar to the ones we did before, I don't want to square root this until this number out here is gone. And ideally, when I square root, I'd like this number over here to be something that has a nice square root, because if not, this gets nasty quick. So I need to get rid of this 1/2. To get rid of 1/2, I'm timesing by the reciprocal. Flip it over, times 2. It's been a little while since we did that, but remember that's how you do it. When you times by 1/2, you take half of something. That's like dividing by 2. So if it said divided by 2, how do I get rid of it? Times by 2. So what happens is this half goes away. I still have 2z plus 3, and I still have the squared. I haven't done anything with that. 18 times 2 is 36, and oh, that's a nice number to square root. So now that I've got this isolated, I'm going to go ahead and square root to get rid of the square. So now I have 2z plus 3, that's it, equals, square root of 36 is 6. I do need to account for both the positive and the negative version. So I'm going to solve this 2 different ways. Once for positive 6, and once for negative 6. So minus 3, you can kind of do these together if you want, minus 3. These will go away. For both of them, you'll have 2z equals. Positive 6 minus 3 is 3. Negative 6 minus 3 is negative 9. Divide by 2. And z equals, man, my handwriting's horrible, I apologize. 3 over 2, which you could go ahead and divide that and get 1.5, a nice number. Divide by 2, so z equals negative 9 over 2, which if you go ahead and divide is negative 4.5. So either or. And I'm going to squeeze this last one in. 13. So we haven't seen one like this. We've got a v squared on both sides. To get it to look like anything we're used to, we only want it on one side. Since they're similar, though, I could subtract one of them from both sides and combine them. So we always use that rule that the smaller of the two is the best to keep things positive. So I'm going to go ahead and minus 3v squared from both sides of my equation. Remember, we can always do things to both sides of the equation, so nothing wrong with what I'm doing here. 10 is alone. 7 minus 3 leaves me a 4v squared minus 15. Pretty straightforward from here now. Basically a two-step with the square root at the end. So I'm going to add 15. So I get 25. Divide by 4. Now if you want, you could leave it like this. I do 25 divided by 4. I get 6.25. So I'm going to go ahead and use that number. 6.25 equals 4's canceled, v squared. And so I'm not done yet. I do need to square root. And you might think, oh, that's going to be a nasty one. But when you take the square root of 6.25, it's actually just 2.5. And so I need the positive and the negative. So v equals positive or negative 2.5.